Hello everyone, this is Suresh. I have come up with another topic called compound microscope. In previous lecture, I have explained about simple microscope. So if you have not gone through that video, please go through it and subscribe to my channel. If you like these videos, please share to your friends. So let's come into the topic. So before we are going to discuss about compound microscope, let me ask a question. What is the advantage of simple microscope? Why we constructed? Simple microscope is helping us to see the smaller objects like 1 millimeter lens, right? So if a simple microscope could able to enlarge the size of the object into the large scales, what is the necessity to build another device called compound microscope? If a simple microscope could able to enlarge the smaller objects into large scales, what is the necessity, right? Have we ever seen, by using a normal convex lens, a bacteria? Through the normal convex lens, have you ever seen the bacteria or the size of an object which is lesser than 1 millimeter? No, right? It is not possible to see the size of the object which is lesser than 1 millimeter by using a normal convex lens, which is nothing but a simple microscope. So we want even more magnifying power of devices. By that we could able to see even the object lengths or heights are lesser than 1 millimeter or approximately equals to 1 micrometer, right? So in that process we have built a device called compound microscope who has more magnifying power. So let us go into this topic. In compound microscope, basically we use two lenses. Both are convex lenses. The lens which is near to the object is called objective lens, and the lens which is near to the eye is called eyepiece, right? So here what I have done, I have placed an object in front of the objective lens. I want a real image produced by the objective lens. Therefore, I have placed an object distance greater than focal length of the object. Greater than the focal length of the objective. And one more point, always remember, the focal length of the objective lens is lesser than focal length of the eyepiece. Keep this point also in your mind. The focal length of the objective lens is always lesser than the focal length of the eyepiece. So let's go into this. What I have done, I have taken an object of height h which is placed in front of the objective lens which is greater than focal length of the objective lens. Therefore, I have taken two light rays. One is passing through the optical center, other one is parallel with the principal axis. The light ray which is parallel with the principal axis, after refraction it converges through the focal length of the objective lens, and the light ray which is taken through the optical center which is undeviated, and therefore these two refracted rays will meet at a point B dash. Therefore finally we will get a real image at point B dash and magnified image of this, right? So I am talking about the first half part about objective lens. I am not completely discussing about eyepiece now, we will discuss later. So when I am talking about objective lens, the object is placed in front of the objective lens at a distance of u0, which is minus because it is in front of the lens, and the image produced by the objective lens is plus v0, and focal length of the objective lens is f0. And what about magnification produced by the objective lens? Magnification produced by the objective lens, because I am talking about objective lens, remember this point. Objective lens. So magnification produced by the objective lens is image distance by object distance, v0 by u0. As the image formed by the objective lens is real, so it is negative magnification. Keep this as 1. Right? I hope till now it is clear to you. Now, if you want to know what is the magnification produced by the objective lens in terms of focal length, we can modify this into, we know 1 by f is equals to 1 by v minus 1 by u. Let us substitute these values in the given equation. What you will get it? 1 by f naught is equals to 1 by v means 1 by v naught, minus of 1 by u means minus of minus u naught, so plus u naught. Send 1 by u naught this side, therefore 1 by v naught is equals to 1 by f naught minus 1 by u naught, and 1 by v naught is equal to, simplify this, f naught minus u naught, and f naught into u naught, and u naught minus f naught. We'll get LCM. Therefore v naught is equal to how much? F naught u naught by u naught minus f naught. Substitute v naught value in the magnification formula, then what you will get it? Magnification produced by the objective lens is equals to minus of f naught u naught by u naught minus f naught whole by u naught. Then what you will get it if you simplify? U naught get cancelled. Finally you will get it. Magnification produced by the objective lens is equals to minus of f naught by u naught minus f naught. This is what the magnification produced by the objective lens. Now, what happens? Let me recall. I have placed an object in front of the objective lens which is greater than the focal length of the objective lens. Therefore, I got a real image and the other side of the lens. Now, if you look at this image now start acting as an object to the eyepiece. Therefore, I have taken two light rays from the object, the image formed by the objective lens. One is parallel with the principal axis, other one is passing through the optical center. Again, if I look at, after refraction, these two light rays are diverging. Therefore, they will never meet at any point. If you extend those light rays, you will see the final image formed by the eyepiece is C dash. Let the height of the image is H dash. Here, there are 2 points. There are 2 possibilities that image formed by the eyepiece. One is the image may be formed at near point or the image may be formed at infinity. What is the first case? If the image formed by the objective lens exactly at the focal length of the eyepiece, then the image, then object distance for the eyepiece will be Fe. Therefore, image will be at infinity distance, right? If any object is at focal length of the lens, image will be at the infinity distance. Other case is near point. If the image formed by the objective lens is lesser than the focal length of the eyepiece, therefore, that means the image will be in between optical center and focal length of the eyepiece. Therefore, it will form virtual, erect and same side of the object. So, this is called near point. So, I am talking about both the cases. If I am talking about near point, the image, final image formed by the eyepiece at least must be at least distinct of distinction. To see the image clearly, the final image at least must be at a d distance, where d is least distance of distinct vision, right? So here final image b is equal to d, remember that. So image formed by the eyepiece, I'll write it as, and u is minus e, because both are in front of the lens. Now, if you clearly observe, in previous lecture as I explained, in simple microscope, whenever an object is placed in between optical center and focal length, the image will be formed same side of the object, right? In the same case, if you look at this structure, now the whole setup is acting like a simple microscope, right? Now the object is for the eyepiece is in between the focus and optical center as like simple microscope. Therefore, for near point, what is the magnification produced by the simple microscope? Because now this setup will act as like a simple microscope. What is the magnification produced by the simple microscope? For near point, MD is equals to 1 plus D by F. Here F is FE because the focal length is for eyepiece we are talking about, right? And what is the magnification produced by the objective lens? Minus F naught by U naught, minus F naught by U naught minus F naught, or minus V naught by U naught. So what is the total magnification produced by the both the lenses? Total magnification for near point I am talking about is equals to magnification produced by the objective lens into, I will write it this as magnification of eyepiece. Magnification produced by the eyepiece. So let me write here. So magnification produced, the total magnification produced if an image is formed, a final image is formed at near point. This is how much? Minus V naught by U naught into 1 plus D by FE, or if you want in terms of focal length, minus F naught by U naught minus F naught into 1 plus D by FE. This is the magnification produced when a final image is formed at near point. Always remember, wherever the image is formed by the eyepiece, it is independent of magnification produced by the objective lens. This is same. Therefore, let me calculate for far point now. That means the final image is formed at infinity distance. The final image is formed at infinity distance and highly magnified, right? What is the magnification formula now? For far point, M naught into ME. What is M naught value? Minus V naught by U naught. And what is the magnification produced in the simple microscope when the image is formed at infinity distance? D by FE. Please, if you have not watched the previous video, please go through it, because in the compound microscope we are using simple microscope, whatever the formulas we have derived, the same formulas. So please go through it once again, or you can write, I'll write here, minus F naught by U naught minus F naught into D by FE. So this is what the magnification produced if the final image is formed at infinity distance. So let me recap what I have done. First, I have calculated the magnification produced by the objective lens in terms of both image distance and object distance, or in terms of focal length and object distance. And the next part I have taken from the simple microscope, because we already discussed, because the whole setup is acting as like a simple microscope now. The magnification produced by the simple microscope when the object is in between the focus and optical center and final image is near point, then this is what the magnification produced. Therefore, total magnification is objective focal magnification into eyepiece focal magnification, and I have calculated in both the formulas, and as well as for far point also I have calculated. And along with this, I will make another video how to solve problems in terms of competitive. In competitive, length of the tube also will play a role. So I will explain this concept in another video. I hope this lecture is useful to you. If you have any doubts, please put your comments on the comment box. If you like this video, please like the button and share to your friends. Please subscribe to my channel. Thank you.